Now we are going to start the second part. Design a minimal DFA that accepts all strings over the alphabet sigma a comma b, where every accepted string w ends with substring s. That means where s is first problem is s equal to a. That means where every accepted string w ends with ab. So now again we have to think about minimum language. Minimum language can be maybe. So minimum language will be maybe. Then where every accepted string ends with m. That means we can start with anything but end with m. So again we'll draw only for m. So if we apply A on Q0, it will go to Q1, and if we apply B on Q1, it will go to the final state. So that is our final state QF. Now, have we applied B on Q0? No. Then if we apply B on Q0, what will happen? Every accepted string ends with A. Then it can start with any combination of input symbol. Then if it starts with B, then it will stay on initial state and then will end with AB. So we have applied A and B on Q0. Have we applied A on Q1? No. If we applied A on Q1, that means we are going to start with any combination of input symbols, then A. After A, if we apply again A, then it will stay on Q. Okay. If we apply B, that means A. That means it will apply B B A A B. So it is ending with AB. That means if we apply A on Q1, it will stay on Q1. After applying B, it will go to the final state. Then, if we apply A on final state, if we apply A on final state, that means and it will not stay on. It will not go or will not stay on final state until it is ending with AB. That means if I give A on QF, then sorry. So if we apply A on QF until it will stay on Q1, when it is going to get the B, then it will go to final state. Okay, and if we apply B on QF, then we apply B on QF for final state. That means if we are not applying AB, then it will not go to the final state. Okay, so it will come back to initial state until it is not getting the AB. It will stay on initial state. Okay, so here, so we can check VB AAB. So V B, A, B. So AB is accepting AAB, AAB, BAB, BAB. Then BB, AAB, A, B, BB, A, B. So BB, A, B, A, B, 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 A, B. Okay, so that is also accepting. So we all know about this transition. It is the state transition diagram, and here Q equal to Q0, Q1, and QF, and sigma denotes A and B, and F denotes QF, and S denotes QC. And we all know about the transition function. So now we are going to solve the next problem. So now every accepted string W ends with substring AA. So again our minimum language would be AA. Then it can be triple A, BAA, or ABBAA, or BAA, BAA. So first we will draw for only A. Now, if we apply B on initial state Q0, then what will happen? Our problem is every accepted string ends with AA. So we can start with any combination of input symbol. That means if we apply B on initial state, then it will stay on initial state. So we have applied A and B on our initial state. Then if we apply B on Q1, what will happen? If we apply B on Q1 until until we are getting AA, it will stay on Q0 or initial state. Then if we apply A on final state, then what will happen? It will stay on final state. Because triple A also ending with AA. So giving A on final state, that means it will stay on final state. It doesn't happen any invalid. It will not contain any error. But if we apply B on final state until it will go to the initial state, until it is getting A. Okay, so that is our minimal DFA for every accepted string ends with AA. Okay, so we can check for this input symbol. A is accepting, triple A is also accepting. Now A, B, B, A, A. So A, B, B, A, A. And B, A, A, B, A, A. Now for these, B, A, A, B, A, A. Okay. So now we are going to solve The third problem, every accepted string W ends with BAB. So for again, we are going to think minimum string will be BAB and AB, BAB, AA, BAB and BAB. Okay. So we'll draw for only BAB. B, A, BAB. So if we apply A on QC, that means any string, our problem is W ends with BAB, but it can start with any possible of input symbol. So again, if we apply A on Q0, it will stay of initial state. So we have applied A, B on Q0. If we applied B on Q1, what will happen? If we apply B on Q1, that means it has started with B. But if we apply B on this, so it will be no error. Because again, we can get B here. So B, AB, it is going to end with B, AB. So no problem for this. Okay. Again, we have applied B here, but we haven't applied A. So if we apply A on Q2, that means so we have started with A or any combinations of input symbol AB, but here if we apply A, that means we have to end with BAB. So if we get here A, then it will go to initial state and we have to end with BAB. Okay. Same thing will happen for QB. Okay. So if we get A here, that means it will go to the initial state. And if we get B, then it will go to the Q1. That means B, A, B. Okay. That is the minimal DFA for the accepted string which are going to end with BA. Okay. Now we are going to the next one. So design minimal DFA that accepts all string over the alphabet A, B, where every accepted string W contains substring S, A, B, B. So A, B, B contains substring. So it can happen. It can be started with. It can be end with. It can be in middle. Okay. So we have to think about the language. So minimum language will be ABB, and after that it can be ABBA, okay, or AAB, ABB, or it can be AAB, ABB, AAA. Same thing we have to draw for the minimum. So accepted string contains this AB. Okay. Then if we have started with any other input symbol like B, there is no problem. Okay. So we have applied AB on Q0. So if we apply A on Q1, right, it will stay on this. Okay. Same. If we apply if we have applied A on Q2, that means we are going to assure it must be followed by B. Okay, it must be followed by B. So, and if what will happen if we apply A and B on Q3? There is no problem if we stay on the final state, because when we are on this state, that means we have reached the final state. After that, that means we are containing ABB. So after that, we are having any combination of AB that will not hamper our automata. So that will not hamper our DFA. Okay, that means in here we have no problem like we have to start with ABB, we have to end with ABB. There is the problem is we have to contain a substring ABB. So it can be started with any input symbol, it can be end with any input symbol, it has to contain just ABB. So when we are on Q3 on final state, that means we have reached. That means we are containing ABB. So it can be end with any input symbol. So we can check this string. So ABB is accepting ABBA. Now this AA, BA, BB. Okay, and this string AA, B, A, B. Okay. So that is our DFA for AB. Now we are going to solve AB. Now we are going to solve AB. So again, contains ABA, that means minimum language will be A, B, C. So it can start with ABA. It can end with ABA. It can contain ABA. Well, the ABA can stay in middle. Okay. So again we are going to think for only minimum string. So if we apply B on initial state, that means there are no problem to start with B, because we have to contain ABA. So there are no problem. So if we apply A on Q1, that means we can stay on Q1. There is no problem, because we are going to have A, B, A. right? So we have applied A on Q2, but if we apply B on Q2, what will happen? If we apply B on Q2, that means it will go to the initial state. Again, when it is going to have A, B, E to reach the final state. And if we apply A on final state, there are no problem. Because when we are on final state, that means we are containing ABA. That's why we are here. So any possible operation of AB can happen. So now we are going to check the input symbols. So ABA is accepting, AB, AAA, BB. So A, B, A,